My name is Luke Choi. I'm a senior at Avon High School, and this is my solution to the 2021 HMMT Geometry Problem 9. So the problem states that we are given a trapezoid ABCD with AB parallel to CD. We define point P as the second intersection of the circumcircle of BCD with the diagonal AC. So that's P right here. And given lengths BC equals 27, CD equals 25, and AP equals 10, they want us to find the length of PM, where M is the midpoint of AB. So first, we're going to make some synthetic observations before proceeding with computation. So what we want to do is extend that to hit a circumcircle of BCD at, say, point Q. And what's nice about this point Q is that we can see that since BQ is parallel to CD and BQCD is obviously cyclic, BQCD is actually an isosceles trapezoid. So that means that BC equals QD, if we draw that in. So BC equals QD equals 27. Moreover, we know that QC is equal to BD by symmetry, but since BD is equal to AD, we know that QC must be equal to AD. So if we write that out, AD equals BD by the given, and that also equals QC from the isosceles trapezoid. But if we angle chase, where if we look at angle BQC here, that's clearly equal to, again by symmetry, QBD. So angle CQB equals angle DBQ. And by supplementary angle, that's just 180 minus angle ABD. But since ABD is an isosceles triangle, angle ABD is equal to angle DAB or DAQ. So if we just sub that in, then we also get that these two angles are supplementary. Thus, DA must be parallel to QC. And since we also have this length relation right here, this means that AQCD is a parallelogram. So what this allows us to do is set up some equations so we can actually solve for MP. The first equation we are going to set up is using the parallelogram diagonal theorem. So if we assign variables, let's say AB is equal to A, AD, we'll set that equal to D, and AC we'll set to C. The parallelogram diagonal theorem states that QD, the sum of the diagonal squared, so QD squared plus AC squared, is equal to 2 times the sum of the lengths of the parallelogram squared, or AQ squared plus AD squared times 2. So AC squared plus QD squared equals 2 times AQ squared plus AD squared. Well, AC is one of our variables, C squared. QD must be equal to 27, 2 times. And since AQCD is a parallelogram, we must have AQ is equal to CD. So that's just 25. And AD is D squared. So this is our first relation that we're going to need. The second thing we're going to notice or use is the fact that we have this cyclic quadrilateral BQCP. We want to use this because we can note that CP and BQ intersect at point A, and that means we can actually just exploit similar triangles, where triangle PB is similar to triangle AQC, and again, this is just angles, where this angle is fixed between both, and this angle is the supplementary angle to this angle, but this is also supplementary to AQC, so these two are the same, so it's just AA similarity. And because of this, we know that the ratios between PM and the Q median of triangle AQC, which would just be this if we let this be n, the ratio between those two is actually just going to be the ratio, the similarity ratio between these two triangles. And that's good because in order to find MP, the standard method would be to use the Stewart's theorem or the median formula. But the problem with that is that BP is not very obvious, and there's no clear, clean way to calculate that. So instead, we want to use reference triangle AQC, since we can get a lot of our variables involved with that. So first, we'll need to find the similarity ratio. But we actually have that immediately, since AP over AQ is simply 10 over 25, or 2/5. So we know that PM is equal to 2/5 of QN. Well, how do we compute QN? Well, we can just use our median formula, or Stewart's theorem. So since AN equals NC equals 1/2 of AC, so 1/2 C. Well, using Stewart's theorem, we have that AN times NC times AC plus QN squared times AC equals AQ squared times NC plus QC squared plus AN. And again, if we sub our variables in, this is equivalent to 1/2 C times 1/2 C times C plus QN squared times C equals AQ squared. Well, AQ again is equal to CD, so that's just 25 squared times 1/2 C plus 2C squared, which is QC is equal to AD, which so it's at D squared times 1/2 C. And we can just divide 1/2 C from everything. So that will just leave 2. And that gives us 1/2 C squared plus 2QN squared equals 25 squared plus D squared. And the key here is to notice that we have a C squared term here and a D squared term here with coefficients in ratio 1 to 2, because that's exactly what we have here. So in fact, if we just rearrange this equation, isolating QN squared, this is simply 25 squared plus D squared minus 1/2 C squared, all multiplied by 1/2, or 1/2 times 25 squared plus, if we pull out this 1/4, 2D squared minus C squared. But if we go back here, we know that 2D squared minus C squared, after rearranging, is simply 27 squared minus 2 times 25 squared. So again, we just have to plug this in here, and that's equal to 1/2 times 25 squared plus 1/4 of 27 squared minus 2 times 25 squared. Well, 2 times 25 squared times 1/4 is 1/2 of 25 squared, so this cancels out with this. So that leaves 1/4 times 27 squared is equal to QN squared. So if we just take the square root of this, well, the square root of 1/4 is 1/2, and the square root of 27 squared is 27. So that ultimately leaves us with QN equals 27 over 2. And remembering that we want PM, which is 2/5 of QN, that's simply PM equals 2/5 QN equals 2/5 27 over 2. equals 27 over 5, which is our answer.